Well, let's take a look at the practice test for Unit 11, so geometric reasoning with circles. This is Part 1. We'll do Part 2 in Unit 12. So it says, refer to the figure at right, identify the terms that best describe the given line, segment, or point. So let's take a look at number 1. That's a line GC, and GC is right here. You'll notice that it just touches at that point C, so that means that's going to be a tangent line. So we'll just write tangent line. We'll make sure it's clear that it's a line. And while we're at it, C down here for 8, that is the point of tangency. Fancy word there, but point of tangency. Let's look at DH. DH goes from here to here. It goes through the center of the circle, so that's going to be a diameter. That would be the best name for that. It is a chord, but it's a special chord because it goes through the center. AE, that goes from the center to the edge, so that's going to be a radius. Line BF, so BF goes like this. So this is called a secant line. If we were to stop that just at B and F and we made it a segment, then it would be a chord, but that's going to be a secant line. So BF is down here. That's a chord. And then A, of course, that's the center of the circle. And rounding it off, AD, and AD, that is also going to be a radius. Okay, so pretty easy, just got to know the vocabulary there. Let's take a look at this next one. So it says some important information. F and H are diameters. So, FH and DC. FH, so this right here is a diameter. And then DC, that right there is a diameter. So a couple of things that we notice on this, and there's no perfect way to do this. You can do it in pretty much any order that you want. But if this is a diameter and that's 100 degrees, we've got 180 degrees between the two of those. So that means this would be 80, and if 25 of them are used here, that makes this 55 degrees. And then all of those are central angles. So if this is 55 degrees, the arc is 55 degrees. If this is 100 degrees, this whole thing is 100 degrees. And I'm going to put a little line from here to here just so we can kind of see that. And then we'll see if we can notice anything else about this. You'll notice that this is an inscribed angle here, angle F. If that's 30 degrees, this has got to be 60. So I'm going to put 60 right here. If this whole arc from DGH, if that's 100 degrees and we use 60 of them here, I can erase this now and I can say, well, this has got to be 40 degrees. And then let's see if we've got anything else here. We've got a diameter right here, so we've broken this up also. We know that this has got to be 90 degrees right here, okay, because that intercepts a semicircle, so that's 90 degrees. Let's see if we know anything else. Let's see, 34 degrees here. We got a little bit left right here. Oh, I know what we can take a look at. Remember how this was 80? That means this is 80. That means that this inscribed angle over here is 40. And then we've got two angles on a triangle, and we know that the third one's got to make it add up to 180 degrees altogether. So this has got to be 40 degrees, so 40 degrees right here, which is an inscribed angle, so this one over here has to be 80. So if this is 80 and this is 34, between the two of those, 80 plus 34, we get 114. Between the two of those, so that means 180 minus 114 is going to be 66 degrees. So that's going to, make that look like 66 degrees there. Okay, let me slide this down here. Run through all of our thinking on that one. There we go. Okay, so erase that. And let's see, so we've got 34, we've got 80, we've got 66. Let's see if we've got anything else that we can do. Let's see, if this is 66, if that arc is 66, this has got to be 33. And then a couple different ways that we could get this angle over here. We could either add the two of these together, and remember we got 114 between the two of those. You can divide that by 2 to get the inscribed angle. Or we can just take, this is 90, this is 33, so that's 123, so this would be 57 degrees right here. Either way, you get 57 degrees on that one. Okay, so let's see if we've got everything here and see if we need to write down anything else. So this is arc GH, so G to H is going to be 60 degrees. Angle DCB, DCB, that's going to be 57 degrees. Oh, DBC, I apologize. DBC, yeah, that's 90 degrees. There we go. And then arc GD, so GD, that's going to be 40 degrees. Got that one so far. And then BC, let's see, BC is from here to here, so that's 66 degrees. Angle BCD, so let's see, BCD, so that's this one right here, so we got our 57 degrees, there's that one. DB, arc DB, so D to B, this entire thing right here, remember that was 114 degrees. FAD, so F, A, and D, so that's going to be this one right here. Ooh, so let's see, we didn't figure that one out there, but we can because the same logic applies here. This is a straight line diameter, so this has got to be 80 degrees. So FAD is 80 degrees. And then HAI, so H, A, and I, so that's going to be 55 degrees. That's a little angle right in here, so 55 degrees. FHD, and this is angle FHD, so FHD, so that's this inscribed angle right there, so that's going to be 40. Arc FC, so arc FC, FC, oh, so that's this big one right here. We would want to, let's double check and make sure. Yeah, so we've got 66 degrees here and we've got 80 here, and 34 here. That means between the two of these we've got 100. So this would be 100, and that kind of makes sense because we've got our diameter here, 180 degrees on this semicircle, 80 of them used over here, so that would be 100 degrees for the two of those altogether. And then arc FGH, so FGH, so this big one around here, so that's going to be the 60 plus the 40 plus the 80. Well, wait just a second, since that's a diameter, yeah, that's going to be a semicircle, so that's going to be 180 degrees. And then angle CDB, so C, D, and B, so that's this one right here, that's our 33 degree angle right there, okay, so 33 degrees. So, whoops, make that 80. Okay, so there are the answers to that one. And let's take a look down here. It says find the value of x. So remember, this is a angle formed by two chords that intersect on the inside. So what we would do is we would add those together. So x is going to be 1/2 of 40 plus 52. So that's going to be half of 92. So x is going to be 46. So we got 46 degrees there. Let's see, this one right here, we've got to figure out what this x is. So that 45 degrees, that inside angle, is going to be 1/2 of the two of those added together. So this is going to be x plus 10. And just for the heck of it and just for good practice, I'll go ahead and put that in parentheses so we can see that we're adding this quantity and that quantity together. So I'm going to multiply both sides by 2, so that's going to be 90 equals, this is going to be x plus 47. If I subtract the 47, I get x equals 43. So there we go right there. And then on this one, remember, this is the one where we say, hey, the two pieces, the product of the two pieces of one chord equal the product of the two pieces for the other chord. So I'm going to do 3 times 6 should be exactly the same as 2 times x. I'm just going to divide by 2, do some cross canceling, and I end up with 9. So x equals 9 right here. Okay, let's flip it over and take a look at the other side. All right, we've got an exterior angle right here, and you'll notice that these are tangent. And I think there are parts of the instructions that say you can assume if it looks like it's tangent, then it is. And remember, if they are tangent from the same exterior point, then the segments are congruent. So this is going to be 7x minus 3 equals 5x plus 1. So I'll move the 5x over to the other side by subtracting. I'll add the 3 to this side, so we're going to have 2x equals 4. So we're going to get x equals 2 on this one. And it does just say solve for x for this part of the instructions. This one right here, again, you'll notice this is a tangent, so we've got a right angle right there, so we can use the Pythagorean theorem. So I'm going to do leg squared, which is 15 squared, plus the other leg squared, which is 10 squared, equals x squared. So this is going to be, let's see, 225 plus 100 equals x squared. So this is going to be 325 equals x squared, and we're going to take the square root. So this is going to lead us to, let's see, that's going to be 25 times 13, so 25 times 13, and that's a pair of 5s. So this is going to be 5 radical 13. Good practice simplifying radicals. 26 is the same as this first one right here. We've got two tangents that are congruent to each other. So this is going to be 4x plus 2 equals 2x plus 8. Move the 2x to the other side, move the 2 to the other side. So I get 2x equals 6, so we get x equals 3 on this one. And so you can see these are not too bad as long as you pay attention to what's going on. We've got a right triangle right here, so I can use the Pythagorean theorem. So I'm going to do legs squared, so that's going to be x squared, plus the other leg squared, which is 8 squared, equals the hypotenuse. But the hypotenuse doesn't just go from here to here, it goes all the way from A to C, and this is a radius. So this is going to be 17 altogether, so that's going to be 17 squared. So this is x squared plus 64 equals 289. If we subtract the 64 from both sides, we get x squared equals 225, and then take the square root and we get x equals 15. And I'm hoping a lot of those perfect squares are ones that you recognize. Let's see here. This is an external angle. It happens to be formed by a tangent and a secant. But so when it's outside, we have to subtract the two arcs. So we're going to say 55 is equal to 1/2 of the big arc, which is 6x, minus the small arc, which is 40. So this is going to be 110 once I multiply by 2, and that's 6x minus 40. I'm going to add 40 to both sides, so we get 6x equals 150. And if you divide that by 6, we get a nice easy answer like 25, so that looks nice. And then on this one right here, again, also this is an exterior angle. I'll go ahead and blow this up just a little bit. Exterior angle, so it's going to be 1/2 of the difference of the big one minus the small one. So 62 is going to be equal to 1/2 of the big one, 141, minus the small one, which is x. So this is going to be, multiply both sides by 2. This is going to be 124 equals 141 minus x. Move the 141 to the other side. Whoops, 141. And then notice that we get a negative 17 here. So when we've got a negative 17, we might start to worry, but as long as we keep that sign right here, this is a negative x, we're going to divide both sides by a negative, or multiply both sides by a negative, and we're going to end up with x equals 17. Okay, come down here, take a look at the next couple. Let's see, we're cruising through this. So we're on number 30. Again, another exterior angle. Notice that this goes through the center. So we've got 84 and 52. So if I do 84 plus 52, and I add those together, I get 136. So this is 180 degrees altogether. So I'm going to do 180 minus 136. So that's going to give me, let's see, 44? Yeah, 44. So this is going to be 44 degrees right here. So now we've got the two pieces. So x is just going to be 1/2 of the big one, which is 84, minus the small one, which is 44. So that's half of, let's see, that's going to be half of 40. So x is going to equal 20, or if you want to put 20 degrees on there, I suppose you could. Let's take a look at the next one. Again, another exterior one, and this is where it gets a little bit tricky, so we got to make sure we're paying attention. This is an exterior angle, so 55 is going to be 1/2 of the big one minus the small one. So the big one is x, and between the two of them, they take up the entire circle. So this is 360 minus x. So this is going to be 360 minus x. And again, this is why the parentheses are important here when we're subtracting. If we're just subtracting one quantity, it's no big deal. Everybody gets the first one right, but people miss that second one. So here's what I'm going to do. I'm going to multiply both sides by 2, so this is going to be 110. And then this is going to be x minus 360 plus x. Minus times a negative x is plus x. So I'm going to move the 360 to the other side. So this is going to end up being 470. Put those two together, so that's going to be 2x, and we're going to divide by 2. So we end up with x equals 235. So that outer one would be 235 degrees, and if they asked us to, we could figure out that little one on the inside there. Again, same thing. This is an exterior one. We don't have a lot of information. We'll wait just a second here, though. So we've got a point right here, and a point right here, and a point right here. If this is 128, and that's 148, and the circle is only divided into those three pieces, we can add the two of those together. So we're going to do 148 plus 128, and make sure I do the arithmetic here, right? So that's going to be a 16 and one more, so that's going to be a 7, and that's going to be 2. So 276 altogether. So let's take 360 and subtract 276. And let's see, so that's going to be a 5 and a 10, so that's going to be a 4. Got to borrow again, so that's going to be 15. So we get 84. Sounds pretty good to me. Yep, because that would take 24 to get us. Yep, yeah, perfect. So this is going to be 84. So the tough part on this one is figuring out what that arc is. And then remember, x is just going to be 1/2 of the big one, 128, minus the small one, which is 84. So we get x is equal to 1/2 of, if we do the two of those together, 128 minus 84 is going to be 44. So we end up with 22. Okay. All right, let's come down and see how many more we've got. We got a few more here. We got, looks like 5 more. So we'll take a look here. Again, exterior angle. Man, lots of exterior angles on this one. This one's going to be 25 equals 1/2 of, the big one's going to be 90 minus the small one, which is 5x. So this is going to lead me to 50 when I multiply both sides by 2 equals 90 minus 5x. We subtract the 90 from both sides, so that gives us a negative 40 equals negative 5x. And again, we're looking for these negatives to cancel off, which they do, so we end up with x equals 8. Okay, and we'll take a look at the next few. Same type of thing on this one, but this one actually ends up being a little bit easier. We've got these 2 points of tangency, so there's 360 degrees altogether. So this 50 is going to be 1/2 of the big one minus the small one. All right, so the big one minus the small one in this case is 360. Whoops, let me make that a little bit bigger, needed a little bit more space. Is going to be 360 minus x minus that small one of x. And you'll notice here it doesn't really matter if we have the parentheses on there or not. So again, I'm going to multiply by 2. This is going to be 100. This is going to be 360 minus x, and again, that wouldn't matter if we had the parentheses on there or not. I'm going to subtract this 360, so we get negative 260 equals negative 2x. We're going to divide both sides by negative 2, and luckily we end up with a positive value because we need that to be a positive. It's an angle measurement right there. Okay, and then we'll slide over, take a look at this guy right here. Same type of thing on this one. We're going to do the 360 minus x. Man, overabundance of problems like this, I suppose. Careful here, it's the big one minus the small one. So we're going to do 37 equals 1/2 of the big one x minus the small one. So this is going to be 360 minus x. Same type of thing happens before. This is going to end up when I multiply. This is going to be 74 equals x minus 360 minus a minus x. So that's going to be a plus x. So we get 74 equals negative 360 plus 2x. Move this to the other side by adding 360. So we'll just do add 360. So we end up with, let's see, what would that be? 434 equals 2x. And then we're going to divide by 2, so we end up with, let's see, that'd be 217. So x is equal to 217, which kind of makes us feel good because that would have to be the bigger of the two pieces because it's more than half the circle. Okay, let me shrink this down just a tad, and then we'll take a look at these last couple. Okay, on this one it says find the measure of angle x and y. One thing we'll notice is that we've got a circle here centered at D, so that makes this one right here a right angle, so that's going to be 90. And then there's a couple different ways that you can handle this. So y on this one is 90 degrees, and what I like to do is say, hey, that means between the two of these acute angles right here, they would have to add up to 90. So x plus 2x plus 6, and I'll go ahead and put parentheses on this to just be careful about this, equals 90 degrees. If you wanted to, you could go the long way and say, hey, I'm going to take the first angle plus the second angle, whoops, I need a 2 in there, plus the third angle, which happens to be a right angle, and set that equal to 180 degrees. But if you move the 90 to the other side, you end up with the same thing. So we're going to get 3x plus 6 equals 90. Subtract the 6, and we get 3x equals 84, which happens to go in there nicely. So if we divide by 3, we end up with x is equal to, let's see, that would be 28. Okay, so we'd get 28 degrees right here, and that's 28 degrees. It did ask for what x and y were. I guess x is just the number 28, and y is just the number 90, but either way, so 28 for x and 90 for y. Okay, and then we're on to the last one. Okay, so let's take a look at this. Tons of information here. We want to find the measure of all of these angles, all of those numbered angles. And it says the measure of, and I'm going to blow this up just a little bit. So the measure of angle 1 is 5x plus 3, so 5x plus 3. The measure of angle 2 is 10x plus 12. The measure of angle 3 is 7y minus 19, and the measure of angle 4 is 2y plus 1. And the key to figuring this out here is that this is a circle centered at U, which means this is a diameter, which means this is 90 degrees and that's 90 degrees. So that means, like we did on the last problem, these two acute angles here, angle 1 and angle 2, they have to add up to 90 degrees. So I'm going to write angle 1 plus angle 2 has to equal 90 degrees. And the same thing for angle 3 and angle 4. So angle 3 plus angle 4 would have to equal 90 degrees. So then we'll just set this up as two different little equations. So this means 5x plus 3 plus 10x plus 12 equals 90 degrees. And I'll do this one in a different color so we can tell what's going on here. So this is, whoops, let me get a different color here. There we go. Do that in blue. So this is going to be 7y minus 19 plus 2y plus 1. That would equal 90 degrees. And again, if we were doing something, whoops, make that look like a 1. There we go. Okay, that would equal 90 degrees. And again, it's this quantity plus this quantity. If we needed to put parentheses around these to make sure that we didn't make any silly mistakes, we probably ought to. But again, with addition, it's not going to make that big a deal. So this is going to be 15x plus 15 equals 90. And then we're going to subtract the 15 from both sides. So we get 15x equals 75. So let's see, if we divide by 15, we get x equals 5. So x equals 5 there. That's not the answer to the problem, though. We got to make sure that we figure out the measure of each one of the angles. On the one for y, this is going to be 9y minus 18 equals 90. So we're going to move this to the other side by adding 18. So we're going to get 9y, let me slide down here, 9y equals 108. And if we divide by 9, we end up with y equals 12, okay? So these are the two pieces that we've got, but now we need to say what the angle measures are. So I'm going to come over here and I'm going to do this I'll do this in another color. I'll do this in green. So the measure of angle 1 is going to equal, we're going to plug in an x. So this is 5 times 5 is 25, plus 3 is 28, okay? And then angle 2, we're going to plug in 5 into that also. So 10 times 5 is 50 plus 12 is 60. Let's see, 10 times, yeah, that should be 62, I believe. Okay, and then the measure of angle 3 and the measure of angle 4. Let's figure out what those are. Let's throw a 12 in. So if I plug a 12 in for y, that's going to be 84 minus 19, and 84 minus 19 is going to be 60. Let's see, 65 degrees right there. And then the measure of angle 4, if I plug a 12 in here, that's going to be 2 times 12, that's 24, plus 1, that's going to be 25, okay? So 25 right here. Okay, so I've got the measure of all of those angles. We've got the measure of angle 1 and angle 2, and got the measure of angle 3 and angle 4. And hopefully we're in good shape. Now, I was yakking the whole time. That took about 25 minutes to do all those problems. Test, I think, will be easier than that and go much quicker. All right, good luck.